Hello students, in this class we will discuss about vector differential operator. Three differential operators are there and they are gradient, divergence and curl. Now we will discuss about the problems related to gradient. So what is gradient? Gradient is denoted with del or nabla, which is defined as gradient or del or nabla is identically equivalent to I dou by dou x plus j dou by dou y plus k dou by dou z. Now we can apply the gradient to the scalar potential function. That is, it is generally denoted with phi of xyz, and we have grad phi or del phi is I dou phi by dou x plus j dou phi by dou y plus k dou phi by dou z. This can be written in the summation notation as summation I dou phi by dou x. It is the sum of three different terms. Depending upon this, we have four important formulas. First one, normal to the surface. Second one is unit normal to the surface. Third one is maximum directional derivative or greatest directional derivative. Next one is normal to the surface. Angle between normal to the surfaces. Normal to the surface phi of xyz is given by del phi, whose unit normal to the surface is given by del phi by modulus of del phi. Suppose a bar is any vector, then whose unit normal vector is given by a bar by modulus of a bar. Like this, a del phi by modulus of del phi is the unit normal to the surface phi of xyz equal to c. The maximum directional derivative is given by modulus of del phi. Suppose we are having two normal to the surfaces n1 bar and n2 bar to the surfaces respectively for phi, f and g. n1 bar is del phi or del f at the point p of xyz, and n2 bar is del g at the point p of xyz, and theta be the angle between two normals. So then we have a known formula, that is cos theta equal to n1 bar dot n2 bar by modulus of n1 bar into modulus of n2 bar. The formula is already known in intermediate, that is cos theta is a bar dot b bar by modulus of a bar into modulus of b bar. Here we have directional derivative formula, which is very important for 5 marks. The directional derivative of the scalar potential function phi at the point P in the direction of a bar. So here the problem is given as find the directional derivative for the scalar potential function at the point in the direction. So what is the direction here? A bar. What is the point here? P of xyz. And what is the scalar potential function? Phi. The directional derivative is given by del phi dot a bar by modulus of a bar. So just we have to take the dot product between del phi and unit normal to the vector a bar. So which gives the required directional derivative. Now coming to the problems, find grad f where f equal to x cube plus y cube plus 3xyz at the point 1, 1, minus 2. So given scalar potential function is f, now we have to compute grad f. Grad f is del f. Del f means I dou f by dou x plus j dou f by dou y plus k dou f by dou z. Just we have to replace the function, so in this place, and we have to differentiate partially with respect to x, with respect to y and with respect to z, which gives del f or grad f. But we have to find out del f at which point 1, 1, minus 2. Just replace x value as 1, y value as 1, z value as minus 2. It is the required grad f. Now coming to second sum, that is find the unit normal to the surface for the function at the point. So given function is f of xyz and given point is p of xyz where x is 2, y is minus 2, z is 3. Here just we have to find out del f at the point 1, 2, minus 2, 3. So and we have to find out the normal to the surface. The normal to the surface is nothing but del f. So it is the required normal to the surface. Coming to next sum, so we have to find out unit normal vector to the surface at the point 2 to 3. So given function, scalar potential function, and given point p of xyz. So here we have to find out unit normal vector to the surface. That means we have to compute del phi by modulus of del phi or del f by modulus of del f. So just we have to find out del f, and then we have to find out del f at the point. Thus the required unit normal to the surface is del f by modulus of del f. So it is the required unit normal to the surface. Now coming to next sum, that is find the greatest value or greatest directional derivative or maximum directional derivative. So it is very important for 2 marks. So here given f and given point p of xyz, just we have to find out del f and then del f at the point 2, 1, minus 1, which gives the required greatest directional derivative or maximum directional derivative. That is given by modulus of del f. Modulus means whose magnitude of del f. Magnitude means suppose there is the vector like a1i plus a2j plus a3k, whose magnitude given by root of a1 square plus a2 square plus a3 square. Now coming to next sum, important one, that is for 5 marks. Find the angle between two surfaces at the point. Just we have to take or write the two surfaces f and g. And we have to compute the angle between two normals. So here we have to find out two normals n1 bar and n2 bar. So this is n1 bar. N1 bar is nothing but normal to the surface del f at the given point, and n2 bar at the point p of 2, 1, minus 1, 2, which is obtained by just by taking x as minus 1 and y as x as 2, y as minus 1 and z as 2. So these are n1 bar and n2 bar. We have a known formula. Suppose theta is the angle between two normals, we have cos theta. So cos theta formula is n1 bar dot n2 bar by modulus of n1 bar into modulus of n2 bar, which gives the required. So it is the required angle between two normals. That is theta is cos inverse of 8 by 3 root 21. Next sum, find the directional derivative of f at the point 1, minus 1, 3 in the direction of I plus 2j plus 3k. So here given scalar potential function f, point p of xyz, direction a bar. So write the given values f, p and del f. Just first we have to find out del f at the point, given point 1, minus 1, 3, and given vector is a bar. So already I told a formula, that is the directional derivative for the function at the point in the direction is del f dot a bar by modulus of a bar. So fix the above values, we will get the required directional derivative. So simple and so easy and important one. Thank you.